Now what should I see if I can do? See if I can simplify. Look at the numerator. Can I add those two together?
No.
No, they're not alike. Could I simplify the square root of 10 to possibly make them alike?
Yes.
No.
No.
10 is 2 times 5. Okay, so that's all I can do. In the denominator, I've got the what? 14. All right, now when we did these types of problems before the break, I told you. Okay? 4 square roots of 10 is being divided by 14. 2 square roots of 5 is being divided by 14. Those are 3 terms. Remember, whole numbers cancel whole numbers. Radicals cancel radicals. So if 4, 2, and 14 can all be reduced by a common number, then I reduce all of them. What can they be reduced by? 2. And when you reduce them, that's how you get 2 square roots of 10 minus the square root of 5 over 7. Because this has been reduced by 2, this has been reduced by 2, and this has been reduced by 2. This is review. This isn't even the lesson yet. This is still review.
I don't think I ever got that far. I got that part.
We have like a quiz on.
All right.
How about we have like a.
We talked about that. Now,
Yeah. Whoa.
we're going to use, this is the new stuff. We are going to use all of these rules because they still apply. But now we're throwing fractions in there. Okay?
X to the half.
All right. Look at this problem. Is that x is being multiplied, added, or are those powers being raised to powers? Okay, so think about it. What's the law of exponents when you do powers to powers? You're supposed to multiply the exponents. All right, now look at the exponents. What are they? They're fractions. How do you multiply fractions? Straight across.
Yeah.
Numerator times numerator, denominator times denominator, right?
Yeah.
Okay? So we know it's a power to a power, so we're going to multiply the exponents. Okay, we got to know how to multiply exponents. Fractions. Just straight across. All right, so let's write this out because I just have the final answer. I've got x to the 1/2 raised to the 2/3. And then I've got y to the 3/4 raised to the 2/3. What is the exponent of x going to be? No, it's not 1/2.
2.
2 over 6 or 1/3. What is the exponent of y going to be? 1/2. 6 over 12 reduces to 1/2. The answer to that problem was x to the 1/3 times x to the 1/2. Okay, now,
Hold on, wait. Relax for 5 seconds.
1, 2, 3.
yes, Dwight, of the radicals? Because these are 2 different radicals, and we don't want to have all that little radical notation going on all over the place. Because one's a cubed root and one's a square root, so they'd have to each have their own little hat. Okay? Which answers the question of what I was about to say. The reason we're writing it this way instead of as a radical is because you would have to have separate radicals. Okay? And it's just ugly. Okay. Now, I put a 3 here, but it could be the same thing as x to the 4/5 times x to the 6/5. Both of those are the same base. Okay? So when you're multiplying 2 things together that have exponents, what do you do with them? What do you do with the exponents? You add the exponents.
Oh, so it'd be like 10 tenths, which would be 1. 10
It's
over
not
5.
10 tenths.
It's 10 over 5, which would be 2 over 1, which would be 2.
Yes.
Wait, why?
Stop. Question?
Why would you add the exponents as long as the bases are the same?
Because the base is a representation of something that can be combined together.
So
If the base is this, as long as it's 3 and 3, you just add the exponents together.
what does make a difference if there's no exponent, right?
If there's no exponent, it's a 1 understood exponent.
No, like because they're not raised to any power. They're not powers raised to powers. Because there's no power outside of parentheses,
Right.
you don't multiply the exponent.
Right.
You lost me.
This is multiplication of something times something. Okay? If it makes it easier by not having a number there and saying, okay, well, x will represent 3, then that means it's x to the 4/5 times x to the 6/5.
Sally, why would you add the numerator and keep the
Okay,
denominator?
Okay,
What do we do with the 3?
listen. Just wait. The 3 just stays like it is until the very end.
Answer's 18. Right?
Okay? No.
Ow.
All right. The law of exponents says that we're going to add them together. Well, the exponents are fractions. So now we got to figure out how do you add fractions. You have to have a common denominator,
Which y'all have.
and you
Oh,
add the
yeah.
numerators, but the denominator doesn't change. Okay? 1/2 plus 1/2 is 2 halves. Okay? So if I'm going to add 4/5 plus 6/5, Tyson said that gives me 10/5 or 2. So the base of this thing is 3. The exponent is squared. What's 3 squared?
3 squared is 9.
9.
So the answer's 9?
The answer is 9.
Wait, why didn't you multiply this?
I did multiply the 3's by adding their exponents together.
We could have just left it. We could have just multiplied 3
No, I couldn't have, because that wouldn't have been the same thing.
It's like the order of
3 times 3 is
operations.
9.
Why is it 9
It's the order of operations.
3 times 3 is 9.
3 times 3 is 9, but if I change the exponents to something else,
You gotta have a whole different
it could change the whole answer.
So
If one was the 3/5 and the 6/5, the whole answer
Oh,
changes.
so Miss Sally, so you just keep it 3, but then you. Now I got it. The exponent's gonna equal up to square. I got it.
You add the exponents, you get 10, right?
Hmm?
You add the exponents, you get
10 over 2. No, 10 over 5, excuse me. 4/5.
You leave the denominator?
Yes, you have a common denominator of 5.
So one
I get it.
4 plus 6 is 10. Okay?
or 2 over 1.
Or 2 over 1, or just 2.
Oh,
Okay?
okay.
All right, let's
I got it.
wait. Let's do an easy one first before we do that one.
We do it with x's.
Let's say we have 5 to the 1/5 times 5 to the 3/5.
Yeah. 45. So what do you do now? Yeah,
The answer is not 25.
Yes, it is.
5 times 4/5. 4/5 of 5 would be 4. That makes no 4.
The bases are the same.
Is equal 4.
You're multiplying,
Oh, now
so
I get
you
it.
add the exponents. So it's 5 to the 1/5
4 is it?
plus 3/5.
5 to the 4.
So it's 5 to the 4/5.
That's the answer?
And that's your answer.
Oh, okay, good.
Okay?
Yeah.
Okay.
No, because you can't find the 5th root of 5 to the 4th power. It's not a perfect number. So you just keep it like that.
So, like, that's the proper
If you found that answer,
Right.
wouldn't it be like smaller than 5?
Hey,
Yeah.
hey, there's no need for this.
Shh. This one just worked out perfectly, okay? But they're not all going to work out perfectly.
You should put them all perfect on the test.
All right. Now,
Oh,
on the last one, y'all stop talking. On the last one, I said as long as your bases are the same, you can simply add the exponents. But what's the problem right now?
Yeah, guys, it's common denominators.
Plus that too. But the bases are not the same. Okay? One is 8, another one is 32.
Everything's
So-
all messed up.
What are we going to do?
Get a common denominator.
Shh.
Yeah.
We're going to make the bases the same. Okay, how?
Times 5.
Now listen, here's where you really need to pay attention.